I think everyone's stayed on past lunch, which is a good sign. You've had a wonderful array of pretty high-level talks this morning. So this one is going to be more of a deep dive, and you actually get to see a bit of code as well. But first, before I begin, quick show of hands, please. Everyone who uses Shiny, any shape or form. OK, so that's most people. And hands up again if anyone who uses Plumber. OK, that's more than I thought. So this is mostly going to focus on Shiny, and you'll see why. But there are some slides on Plumber as well. So I'm going to be talking about the Mirai package. So this is something that I've been developing over the past year or so with some first-rate collaborators who will be mentioned in the talk. So mirai is Japanese for future, and I'm calling it mirai, but I know it's mirai. Actually, the R in Japanese is pronounced more like an L, and I just want to mention that because I think this talk is being recorded. So for posterity, I don't want someone to come and be like, he doesn't really know what he's talking about even. But as you're an English-speaking audience, I'm going to say mirai because that's probably more natural for everyone. But of course, I'm talking about the CRAN package mirai, and the description basically says lightweight parallel code execution and distributed computing on local and network resources. So what does that mean? So let me just show you very quickly, so we're not talking about generalities, but just show you that it's really simple to run parallel computations. The main function of the package is simply called mirai, and here we're asking it to compute the expression a plus b in a separate process. So that process, by default, will just be a background process on your local machine, but that can be across the network. It can be on the cloud, or it can be on a high-performance compute cluster. And here you'll notice that because a and b, the expression, both variables are not defined, so we're just telling it that a equals 1, b equals 2. So if we look at the object, if we just print the object that's returned, then helpfully says that it's a mirai and it suggests that we query the data element. So if we do that, and then assuming that that computation is still ongoing, and of course here it's just a plus b, but you can imagine that could be something that takes hours or even days, then while that's still ongoing, it will just return an unresolved value, which is just an NA, but it's a class NA. And then at this point, your R session is not blocked, so you can do whatever else that needs to be done. And then when you actually need the result of the computation, you just do call mirai m, and that waits for it to complete if it hasn't already finished. And then if you want the data again, then you get the answer, which in our case is just simply 3. And you're thinking, what's so special about this? A lot of you will have used a package like Future before. You might have used call.R or something like process.X even to run computations on other processes. Well, there are reasons, but why do you actually care about this, right? And possibly because of this guy. And so Joe Cheng, the creator of the Shiny framework, gave this talk about 2 weeks ago at Epsilon ShinyConf. And the title of his talk was Beyond Async. And this is about the latest feature in Shiny called ExtendedTask. And in that talk, he mentioned mirai as a way of launching these extended tasks. So it would be a lie for me to say that he recommended mirai, but he did mention it. So at least I think he didn't think it was a terrible way to launch these tasks. Otherwise, he probably wouldn't have mentioned it. And why would he mention it? Well, let me go through some of the positives of the package. And the first one is it's highly performant. And why is it highly performant? Because it uses another package, which is quite special in that all the functions in that package look something like this, which is a single line, which for those of you who actually code in R, is just a call down to C code. And that C code will look something like this, and it's much longer. But you effectively, this is the difference between the speed of compiled code versus interpreted R code. And to borrow something from Andre's presentation this morning, this is a 10 times performance improvement. This can be easily 10 times. So yes, it's fast, and why is it fast? NanoNext itself is a binding for NNG, Nano Message Next Generation, and that is the state of the art in messaging concurrency. And it's a C library written by the author as a reimagination of zero.MQ, which is quite a widely known messaging library, but it's been rewritten in the C language to make it even more scalable than zero.MQ. And why is that important for Shiny? Well, if you're deploying Shiny in production and you want to serve your app over 1,000 servers, then the underlying framework, NNG, is not going to really cause it to break out the sweat even. And the other thing about NNG is it is designed for high throughput. So it can handle millions of messages, even tens of millions of messages a second. And so if you're using R, again, we're not really going to be pushing the limits of NNG because we're going to be limited by the speed of the R interpreter. And NNG itself is used in a lot of industrial contexts, including in the middle at CERN, presumably for some high-powered applications. And this is the most important slide of the whole presentation. It's probably not the prettiest slide, but another reason why Mirai is so fast is it's completely event-driven. So if we talk about asynchronous programming, then there are no loops of this kind in any of the stack that's in Mirai or under Mirai. And what I mean here is there's nothing in the code that basically says, oh, check has this thing finished. If it hasn't finished, then check again in 0.1 seconds or whatever it is. And why is that important? Well, there are no loops even for promises. And for those of you who are familiar with promises, that's exactly how they work. So if you're using Shiny and you're using future with Shiny or using a future promise in Shiny, there's code that basically looks like that. Has the promise resolved? If it's not, check again in 0.1 seconds. And sort of, by and large, that's been okay if you have one or two promises. Doesn't cost that much time to do that check. But if you have a more complex application, and say you have 1,000 promises, and each of them takes a millisecond to run, and you're checking every 100 milliseconds, then you're going to run into problems. So this is a world-first announcement on Saturdays. We've solved this problem. Mirai promises run like the rest of the Mirai package, completely event-driven, no loops of this kind. It scales to a case with thousands of promises. And I have a collaborator who's tested this, and he's confirmed that a Shiny app that actually uses thousands of promises feels noticeably snappier and faster and responsive because of that. And this is, again, this is something that I've developed in collaboration with Joe Cheng himself. This idea actually came from him, and I simply implemented it in the Mirai package because it's especially suited to the type of concurrency that Mirai implements. And exactly, it's because it utilizes features of the underlying library. The second important point I want to mention about Mirai is that the design has been kept simple. And the reason it's been kept simple is that simplicity makes it robust. There are other frameworks where they've gotten to the stage where the code base is so complex and sprawling that when a user reports an error or an issue on GitHub, then the maintainer doesn't necessarily know what's causing the problem. And so some of these issues take a very long time to be resolved. But for Mirai, it's been designed for simplicity. So the code base is only about 500 lines of code in total. That in itself means that there's very little overhead. So we retain most of the performance gains from that we saw earlier. And that also means that there are fewer points where things can fail in the package. The interface is also minimal, as we saw on the first slide. There's not really that much else that you need to know to get started using this package. And that doesn't mean that it doesn't have features. They're all built in. And we'd like to think that we've just chosen good defaults for you. Another reason we've kept it simple is to make sure that your code is correct at all times. And that's important when you're developing code that's going to be put into production. So you're not just writing a script interactively to get some results, but it's going to be on the server, it's going to be running 24/7. And this is an example of how Mirai works. So you might have A, B, and C already defined in your environment, but if you look at the expression that you're asking the Mirai to perform, A, B, and C are not defined there. Only Y is actually defined. So we have to tell the Mirai that A equals A, B equals B, C equals C. So we're requiring this level of explicitness to make sure that your code is always correct. Because the way that it's been done by certain other packages and frameworks is there are other whole packages which try to infer what A, B, and C is by inspecting the code. And that may work when it's very simple like this, but code is rarely as simple as this. So they do suffer from bugs, and it can make mistakes. And the point I want to make here is it may seem a bit more cumbersome to write that extra code, but writing code is fast comparing to debugging code. So in the long run, personally, I'd make this trade-off. I'd rather be more explicit and not have code subtly failing and then trying to work out what went wrong. However, we have a new feature which makes this a little bit more ergonomic, in that instead of passing each variable, we can just pass the environment to the Mirai as well. And that just passes everything that's already in your calling environment. And that works very well with Shiny in particular, as we'll come to in a bit. And the last thing I want to mention about Mirai before we actually get into Shiny code is that it's been designed from the outset for production. And what I mean by this is that I've been working with Will Landau, who's the author of the Targets reproducible pipeline ecosystem, and it's really an ecosystem. There are packages, stand targets, JAGS targets. There's even a targets package to handle SQL queries now. So it's for applications where you need to orchestrate pipelines, and it keeps all of these pipelines current. But it's I've been developing this package for him, and he's developed a package called Crew, which extends Mirai to these high-performance computing environments, which includes traditional clusters and the cloud. And Crew is now the default high-performance computing backend for targets. And that means that it has been adopted, has seen quite wide adoption in the life sciences industry. And the applications include things like running Bayesian simulations for clinical trials, where computations are parallelized over thousands of high-performance compute cores. Mirai has also been integrated with base R. So this is something that came out of the project sprint last year, which was held in Warwick, led by Heather. Thanks to Heather. And Mirai has been added as the first alternative backend for the base parallel package. And why that's relevant for you, Shiny users, well, we actually did quite a bit of work on ensuring statistical correctness for random number generation in these parallel processes. So that was something non-trivial that we ensured that Mirai is correct in that respect. And so if we call the Mirai make cluster function, that basically creates a Mirai cluster, and you can use all your parallel functions in the same way as the clusters that you had previously. Great. So this is my cue. How did we get here? And this was a title that was part of Joe Cheng's talk. So here we stopped talking about Mirai and we join onto Shiny. So I'll give you one slide quick summary of what he covered in his talk. So async programming was introduced a few years back, quite a number of years now. But back in 2017-18, these packages, latent promises by Joe Cheng, basically introduced async programming. But according to Joe himself, Shiny async was never truly satisfying. And the reason why is Shiny async allowed different sessions to occur at the same time. So it supports multiple users. But for each individual user, the process was still not responsive. So if you had a long-running task, that would still block the process for each individual user. And the reason it did that is because, for any of these async tasks, it can be either in a state of yet to finish or it can be finished. And that affects everything that depends on it. So if you think of the Shiny sort of dependency graph, then it basically blocks that cycle from refreshing because it's not safe for the downstream outputs to assume that something is finished. Until now, that is. With the latest feature on the latest release of Shiny, Joe implemented ExtendedTask. And that's a very elegant solution that frees up this reactive cycle. And the way he does that is that he makes every Shiny object aware that something could be an extended task. So that means an output that depends on an extended task will know, OK, don't wait for it to finish. Just update when it's finished. So that allows intra-session responsiveness. And that's the newest, shiniest Shiny thing out there. And this is a full application that uses ExtendedTask, and I'll give you a live demo. Okay. So the important thing here to notice is the last line, which is with daemons 3 run app. So daemons 3 just means that you're launching 3 background processes, so you can process 3 computes at the same time. And so this is just something that, let's say we have 6 of these, and then press these buttons at the same time. You can see the first 3 have all finished, but there was a wait of 5 seconds for the bottom 3 to finish. So this shows that it's all happening at the same time. And so while this is all going, the app remains responsive. So if we add more, that works. And this is essentially ExtendedTask. It allows intra-session responsiveness. Okay, so if we just break these out, and I appreciate this is probably not the best format to go into code, but I just want to show you how simple it is, and there are only 4 steps you need to take advantage of ExtendedTask. So in the UI, you create one of these input task buttons, and all this is a nicer action button. And the way it's nicer is that once it's clicked, it disables itself automatically, so it prevents a user from just repeatedly clicking the button. And then in the server, you just call ExtendedTask. You call the new method on this ExtendedTask, and you pass it a function that it just pass dots to a mirai expression. That's all you have to do. And then you create an observer on the input button, so it will run when the button is clicked, and you call the invoke method of the ExtendedTask, and you pass it the inputs that are required to the mirai. So here, the x and y, the mirai requires x and y, so you tell it x equals input n, and then y is the input delay. And then for your output, all you need to tell the render function is take the result of the ExtendedTask. And that's all there is to it. There is another way, which just uses the environment trick we saw before, but it's not important to go into that. I have about 2 minutes to go into Plumber. And I've included this because if you look at this again is a simple sample application that just echoes the request header that's passed into this application. But if you look at the form of this, right, it's very similar to Shiny in that it's an anonymous function, rec_res, right? So instead of the ... we have this form which is rec_res, but you're essentially passing an anonymous function to a mirai. So conceptually, it's similar to the Shiny case, and it works in a similar way as well. So I'm just going to give you 3 quick tips on how to use mirai with Plumber, and that's the data you actually pass into the mirai, only pass the parts of the request that you actually need, so don't pass the whole request object. And then in the mirai itself, return a list with what you actually need returned. And then you use a promise back in the router process to assign the parts of the list back into your response object. And again, that's all you need to use mirai with Plumber. Great, thank you. And that is the end of the talk. Mirai, I've developed with some fantastic collaborators, and we're really looking to push the boundaries of the R language, and we hope that it makes things easier and faster for you. Thank you.